Hey everybody, in this video we're going to do a couple more u-substitution problems. This topic's really just about practice. You try a few on your own, you see a couple more examples, you try a few more on your own, you repeat until the process is totally clear. There's not a whole lot of theory in this topic. Here are the two problems we're going to tackle. They're both pretty typical u-substitution problems. In each case, you want to start by choosing what your u is going to be. And you want to pick your u to be the inside function, a function that is inside of another function. Here, 3 minus 8t sits inside of the cube function. So that's our u. After that, the next few steps are always the same. Differentiate, and then solve for dt. Solve for the differential that appears in the integral. So here I multiplied both sides by dt and then divided both sides by -8. After that, you're ready to substitute. Take out the 3 minus 8t and replace it with u. Take out the dt and replace it with -1/8 du. We're left with an integral that only has u's in it. There are no t's left in this integral. Even better, the integral is one that we know how to do just using our basic understanding of antiderivatives. So the way we're going to anti-differentiate -5/8 u to the -3rd is by raising the power by 1 and then multiplying by the reciprocal of that new power. Tiny bit of simplification gives us 5/16u squared plus c. Great. Now, the original problem didn't have any u's in it. U was a variable we made up, so our answer should have t's, not u's. So let's take out u and replace it with what it's equal to, 3 minus 8t. Here's our final answer. As always, we can check our work by differentiating and making sure that we get the integrand of our original problem back. Problem 2. The integral of secant squared of the square root of x over the square root of x. So the numerator here actually has 3 functions in it. There's a function inside of a function inside of another function. First we evaluate the square root of x, then we plug that into secant, then we square it. However, we know how to get an antiderivative for secant squared. So really the only thing we're concerned about as an inside function here is the square root of x. That's our u. U equals x to the 1/2. I differentiate it and then solve it for dx. So once you know what your u is, your next couple of steps are always the same. Differentiate and solve for dx. In this case, I get dx equals 2 square root of x du. Then you're ready to substitute. Take out square root of x, put in u. Take out dx, put in 2 square root of x du. Simplify, and hopefully you're left with something that only has u's in it and which you know how to integrate. In this case, that's the case. So the most general antiderivative of secant squared of u is tangent of u plus c. Then of course we want to get the u out and replace it with the function of x. So overall in this case we get that the integral of secant squared square root of x over the square root of x is 2 times tangent square root of x plus c.